Welcome to SSL Proxy Load Balancing. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today we're diving deep into SSL Proxy Load Balancing in Google Cloud Platform. This is one of the 7 distinct load balancer types that GCP offers, specifically designed for non-HTTP SSL/TLS traffic that needs global distribution. SSL Proxy Load Balancer is often misunderstood because it sits between the more common HTTP/HTTPS Load Balancer and TCP Proxy Load Balancer. It's perfect for encrypted protocols that aren't HTTP, for example, MQTT over TLS, custom encrypted protocols, or legacy SSL applications. In this presentation, I'll walk you through the complete configuration process for both the global SSL Proxy Load Balancer and the newer regional SSL Proxy Load Balancer. We'll examine every command, explain each parameter, and understand how the components work together. By the end, you'll know exactly when to use SSL Proxy Load Balancing, how to configure it step by step, and what best practices to follow for production deployments. Understanding SSL Proxy Load Balancer. Before we dive into configuration, let's understand what makes SSL Proxy Load Balancer unique and when you should use it instead of other load balancing options. SSL Proxy Load Balancer is a Layer 4 load balancer that terminates SSL/TLS connections at Google's edge locations. It then establishes new connections to your backends, which can use either SSL or plain TCP. This provides several benefits. SSL offloading reduces computational overhead on your backends. Global Anycast IPs provide low latency worldwide, and Google handles SSL certificate management at the edge. The key difference from HTTP/HTTPS load balancer is that SSL proxy doesn't understand application layer protocols. It can't do URL-based routing or header manipulation. It simply proxies encrypted TCP connections. This makes it perfect for non-HTTP encrypted protocols. Compared to TCP Proxy Load Balancer, the main difference is SSL termination. TCP proxy passes through encrypted traffic without terminating it, while SSL proxy terminates the SSL/TLS connection. This allows SSL proxy to offload encryption overhead and provide better integration with Google's security features. Common use cases include MQTT brokers with TLS encryption, custom application protocols over SSL, database connections with SSL, though Cloud SQL proxy is often better, and legacy applications that use SSL but not HTTP pages if your protocol is HTTP based. Use HTTP/HTTPS load balancer instead for its richer features. One important limitation: SSL Proxy Load Balancer doesn't preserve client IPs. The backend sees the load balancer's IP as the source. Client IP information is available through proxy protocol headers if your application supports them. Global versus regional SSL proxy. Google Cloud offers both global and regional SSL proxy load balancers, each with distinct characteristics and use cases. Understanding the differences is crucial for making the right choice. The global SSL proxy load balancer uses Google's premium network tier and provides a single Anycast IP that works worldwide. Traffic enters Google's network at the location closest to the user, then travels on Google's private backbone to your backends. This provides the lowest possible latency for globally distributed users. The regional SSL Proxy Load Balancer is a newer addition that operates within a single region. It can use either the premium or standard network tier, making it more cost-effective for regionally focused applications. Traffic enters and exits Google's network in the same region as your backends. The global option is ideal when you have users worldwide, need automatic failover across regions, or require the absolute best performance. The Anycast IP means users are automatically routed to the nearest Google Edge location, and you can have backends in multiple regions for high availability. The regional option is better when your users are geographically concentrated, cost is a primary concern, or regulations require data to stay in specific regions. With the standard network tier, you can reduce egress costs by 24 to 40% compared to the premium tier. Both options support the same core features: SSL termination, health checks, connection draining, and session affinity. The main differences are scope, network tier options, and cost. The global option requires the premium tier and costs more, while the regional option offers flexibility in network tier selection. In terms of configuration, the commands are very similar. The main difference is the scope flag. The global SSL proxy uses the global flag, while the regional one uses the region flag. We'll see this pattern throughout the configuration process. Step 1: Creating health checks. The first step in configuring an SSL proxy load balancer is to create health checks. These checks are critical, as they determine which backend instances will receive traffic. Let's go over each parameter in detail. The gcloud compute health checks create command supports multiple protocols. For an SSL proxy, you would typically use either SSL or TCP. The SSL protocol attempts an SSL handshake, which verifies that your application can establish SSL connections. The TCP protocol, on the other hand, only checks if the port is open, making it simpler but less thorough. The port parameter specifies which port to check. This should match the port your application is listening on. Common values are 443 for SSL, but it could be any port, like 8443 or 8883 for MQTT. The health check will connect to this port on each of your backend instances. Next, the check interval parameter determines how often, in seconds, to check each instance. The default is 5 seconds. While shorter intervals can detect failures faster, they also generate more load. For a production environment, an interval between 5 and 10 seconds is typical. The timeout parameter sets how long to wait for a response, with a default of 5 seconds. You should set this value based on your application's expected response time. The healthy threshold parameter defines how many consecutive successful checks are needed to mark an instance as healthy. The default is 2. Similarly, the unhealthy threshold sets the number of failures required to mark an instance as unhealthy, which also defaults to 2. Keep in mind that lower thresholds allow for faster failure detection, but they can also be more sensitive to temporary issues. For global load balancers, you'll add the global parameter. For regional ones, add the region parameter and specify the correct region. This scope must match the scope of your load balancer. You can also add a description to document the purpose of the health check, which is very helpful for future maintenance. Finally, the health check name should be descriptive. For example, MQTT-SSL Health or App TCP Health. You will reference this name later when you create the backend service. Step 2. Creating backend services. The backend service is the heart of your load balancer configuration. It defines how traffic is distributed to your instances and includes many important parameters. Let's examine each one. The gcloud compute backend services create command starts with the service name. Choose something descriptive like MQTT backend global or app backend regional. The protocol parameter must be SSL for an SSL proxy load balancer. This tells the backend service what kind of traffic to expect. The health checks parameter references the health check you created earlier. This is required, as the backend service uses it to determine which instances can receive traffic. For global backend services, the health check must also be global. For regional services, they must be in the same region. The timeout parameter sets the backend service timeout in seconds. The default is 30 seconds. This is how long the load balancer waits for a backend response before considering it to have failed. For long-running connections, you might want to increase this. For an SSL proxy with persistent connections, timeouts are less relevant than for request and response protocols. Session affinity is controlled by the session affinity parameter. Options include none, which is the default, client IP, or client IP proto. With client IP, connections from the same IP go to the same backend. This is useful for stateful applications. Note that with an SSL proxy, the client IP is actually the Google Edge location IP, not the real client. The global flag creates a global backend service for global load balancers. Alternatively, use the region parameter for regional load balancers. This must match your overall load balancer scope. Global backend services can have backends in multiple regions, while regional ones are confined to a single region. Connection draining is configured with the connection draining timeout parameter. This is how long to wait for existing connections to finish when an instance is being removed. The default is 300 seconds, or 5 minutes. For applications with long-lived connections, you might want to increase this to avoid disrupting users. After creating the backend service, you need to add your actual backends, which can be your instance groups or NEGs. This step has several important parameters that control load distribution. The gcloud compute backend services add backend command connects your instances to the backend service. The backend service name comes first, followed by the backend specifications. For managed instance groups, use the instance group parameter with the MIG name, and either the instance group zone or instance group region parameter to specify its location. The balancing mode parameter is crucial. For SSL proxy, you typically use connection mode, which balances based on the number of concurrent connections. Unlike HTTP load balancers that can use rate or utilization modes, SSL proxy is limited to connection mode because it doesn't understand request and response patterns. With connection mode, you set the max connections parameter to specify the maximum number of concurrent connections per instance. For example, max connections equals 1000 means each instance handles up to 1000 simultaneous connections. When instances approach this limit, new connections go to other instances. Set this based on your application's capacity. For managed instance groups with autoscaling, you can use the max connections per instance parameter instead. This sets a per instance limit that works better with dynamic instance counts. The autoscaler can use this information to scale based on the connection count. The capacity scaler parameter adjusts the effective capacity of this backend. The default is 1.0, which is 100%. Setting it to 0.5 means the backend is treated as having half its specified capacity. This is useful for canary deployments or when backends have different performance characteristics. For global backend services, add the global parameter. For regional services, add the region parameter, followed by the specific region name. Remember that global backend services can have backends in multiple regions, enabling cross-region load balancing and failover. Regional backend services can only have backends in their region. Step 4. SSL certificate management. SSL certificates are essential for an SSL proxy load balancer. You have several options for managing certificates, and each one uses different commands and parameters. For self-managed certificates, use the gcloud compute SSL certificates create command. The certificate parameter points to your certificate file, in PEM format, and the private key parameter points to the private key file. These files must be accessible from where you run the command. The certificate should include the full chain if you have intermediate certificates. The command looks like this. gcloud compute SSL certificates create my cert, with the certificate parameter set to path/to/cert.pem, and the private key parameter set to path/to/key.pem for global load balancers. Add the global flag. For regional load balancers, which are in preview, add the region parameter and specify your region. The certificate name, my cert, in this example, is what you'll reference later. Google managed certificates are simpler, but they only work with global load balancers. For these, use the command gcloud compute SSL certificates create my cert, with the domain's parameter set to example.com, www.example.com, and include the global flag. Google handles renewal automatically. For the domain validation to work, The domains you specify must point to your load balancer's IP address. For advanced certificate management, Certificate Manager provides more features. You can create certificates with the gcloud Certificate Manager certificates create command and then reference them in your load balancer. This supports wildcard certificates, multiple SANs, and integration with external CAs. You can attach multiple certificates to handle different domains. The load balancer uses SNI, or server name indication, to select the appropriate certificate based on the client's requested hostname. This allows you to host multiple SSL services on the same IP address. Regarding certificate requirements, the certificate must be valid and not expired. It must include the domains your clients connect to, and it must be in PEM format. For production, use certificates from trusted CAs. For testing, self-signed certificates will work, but your clients must be configured to trust them. Step 5. Creating target proxy and forwarding rule. The final steps involve creating the target SSL proxy and forwarding rule. These components tie everything together and make your load balancer accessible from the internet. The gcloud compute target SSL proxies create command creates the target proxy. This is what actually terminates SSL connections. The backend service parameter references the backend service you created earlier. The SSL certificates parameter lists one or more certificates to use for SSL termination. An important parameter is proxy header. Options are none, which is the default, or proxy v1. The proxy protocol header includes the original client IP and port, which is otherwise lost in proxy mode. Your backend application must support parsing these headers. Many applications like HAProxy, Nginx, and custom apps can be configured to understand proxy protocol. For example, gcloud compute target SSL proxies create my SSL proxy, with the backend service set to my backend, SSL certificates set to my cert, proxy header set to proxy v1, and the global flag. The target proxy name is referenced by the forwarding rule. The forwarding rule is created with the gcloud compute forwarding rules create command. This reserves an external IP and directs traffic to your target proxy. The ports parameter specifies which ports to listen on. For SSL proxy, you can specify multiple ports or port ranges, such as setting ports to 443, or for a range, 8443 to 8445. The target SSL proxy parameter references the target proxy you just created. For global load balancers, use the global flag and optionally the IP version flag, which can be IPv4 or IPv6. For regional, use the region parameter set to your region and specify the network tier with the network tier parameter set to premium or standard. To use a specific IP address, add the address parameter and provide the IP address. Otherwise, a new ephemeral IP is assigned. For production, you should first reserve a static IP with the gcloud compute addresses create command and then reference it. This ensures your IP doesn't change if you need to recreate the forwarding rule. The final steps involve creating the target SSL proxy and forwarding rule. These components tie everything together and make your load balancer accessible from the internet. The gcloud compute target SSL proxies create command creates the target proxy. This is what actually terminates SSL connections. The backend service parameter references the backend service you created earlier. The SSL certificates parameter lists one or more certificates to use for SSL termination. An important parameter is proxy header. Options are none, which is the default, or proxy v1. The proxy protocol header includes the original client IP and port, which is otherwise lost in proxy mode. Your backend application must support parsing these headers. Many applications like HAProxy, Nginx, and custom apps can be configured to understand proxy protocol. For example, gcloud compute target SSL proxies create my SSL proxy, with the parameters backend service my backend, SSL certificates my cert, proxy header proxy v1, and global. The target proxy name is referenced by the forwarding rule. The forwarding rule is created with the gcloud compute forwarding rules create command. This reserves an external IP and directs traffic to your target proxy. The ports parameter specifies which ports to listen on. For SSL proxy, you can specify multiple ports or port ranges. For example, ports 443 or ports 8443 to 8445. The target SSL proxy parameter references the target proxy you just created. For global load balancers, use the global flag and optionally the IP version flag, which can be IPv4 or IPv6. For regional load balancers, use the region parameter and specify the network tier with the network tier parameter as either premium or standard. Now, let's discuss testing and best practices. After your configuration is complete, thorough testing is essential. Let's go over some testing approaches and production best practices for SSL proxy load balancers. For testing, start with basic SSL connectivity. You can use the command open SSLS client connect your IP:443 server name your .domain.com to test the SSL handshake. The server name parameter sends SNI, which tests the certificate selection. You'll want to verify that the correct certificate is presented and that the connection succeeds. Next, test the load distribution by connecting from multiple clients. With session affinity disabled, your connections should distribute evenly across the backends. You can monitor the backend metrics in the Cloud Console to verify this distribution. For applications that use connection pooling, make sure the pools are sized appropriately. To test failover, you can either stop instances or intentionally cause them to fail their health checks. New connections should then route only to the healthy instances. Existing connections might be disrupted. This is expected behavior for an SSL proxy, as it cannot migrate active SSL sessions. Using connection draining will help minimize this disruption during planned maintenance. Moving on to production deployments, always use static IP addresses. You can reserve them with the gcloud compute addresses create command. This ensures your DNS records don't need to be updated if you have to recreate your resources. Be sure to configure Cloud DNS with appropriate TTLs that match your failover requirements. You'll also want to monitor key metrics, such as SSL handshake latency, backend connection errors, and the health check status. If you are using self-managed certificates, set up alerts for certificate expiration. Use cloud logging to troubleshoot any connection issues. The SSL proxy logs include detailed information for this purpose. Some security best practices include using strong SSL policies with the gcloud compute SSL policies create command, enabling only TLS 1.2 and higher, and removing weak ciphers. You should also regularly rotate your certificates and keys. Finally, consider CloudArmor for DDoS protection. Keep in mind that it has limited features with an SSL proxy when compared to an HTTP/HTTPS load balancer. Thank you for your attendance. Please consider subscribing to the channel.